energies of element with consecutive atomic numbers below 20 are shown in the following tables. Okay, so this is very important. This is a hint that you should be aware of. Okay, elements with consecutive atomic numbers below 20. So maksudnya dia berturutan. Okay, alright. So we have P, Q, R, S, T, U, V until X. Okay, the first question, A, plot a graph of first ionization energies against the element. Okay, alright. So for A, you just plot a graph, have your axis of this is first IE, okay, in kilojoule per mole, and then versus the elements. Versus the elements. Astaghfirullahalazim. Okay, alright, so let's say we're gonna start with Q, R, S, and so on. Okay, so just plot the graph using the data given to you, right, without the P. Okay, without the P. So it should be easier lah because all the information have been given. Okay, alright, so this is how your graph should look like. Okay, P, just ignore the P because we do not know the value. Okay, so start with Q, R, S, T, U. So we have P lah. Okay, so P without the value. Okay, alright, moving on. Explain why there are hiccups on the first ionization energy between element R and S and between U and V. Hiccups, or we could also call it as anomalies. Okay, so far we have learned that for ionization energy, for first ionization energies, we have anomalies for group. For group, anyone? Which group have anomalies in their first ionization energy?
2 and 3, 15 and 16.
Okay, sorry saya sound amat badan tak dengar. Okay. Whoever answered just now, could you please repeat your answer? Not this one. Okay.
Group 2 and 3, 15 and 16.
Alright, okay, good. Thank you for the response. Okay, so we have group 2 and group 15. Okay, yang membuat ONA ni group 2 and group 15. Okay, we compare group 2 and with group we compare group 2 with group 3. We compare group 15 with group 16. Okay, alright. So we could predict that the hiccup may come from these two groups. Okay, alright. So that gives us indicators. Okay, give us an indicators to set the group for all these unknown elements. Okay, alright, kat sini kita dah highlight tadi kan, R, S, U, V. Okay, alright, so we expect, okay, based on anomalies that we have learned before this, group 2 elements are supposed to have lower ionization energy. So that is based on the trend, tapi dia tak follow the trend. Okay, dia abnormal. Instead of having lower energy, group 2 has higher energy than group 13. Okay, alright. So kita boleh predict that, okay, ini kan higher, this is lower, right? So we could predict that this is group 2 and this is group 13. Okay, kita nak predict, okay? Sebab later kita kena selesaikan P ni nanti later. Okay, and then U and V. If this is group 13, then this should be group 15 lah. Okay, this should be group 15 and this is 16. Okay, alright, so we have 2, 13, then this one should be 14 lah kan, 15, 16, 17 and 18. Ikut trend ikut trend. This is across a period lah, across a period. Consecutive atomic numbers below 20. Okay, so if this is group 2, that means this is group 1. Okay, kalau based on first ionization energy punya trend. Okay, alright. Explain why there are hiccups tadi kan. Okay, so kita dah predict. First kita nak kena tahu where the hiccups belongs to which group. Okay, so kita dah determine. Okay, this R come from group 2, U come from group 15. Okay, dah settle dekat situ. Once kita dah tahu that, okay, we will be able to determine why there is hiccup. Kenapa hiccup tu? Why the anomalies, okay, happen for group 2 and group 15. Kita dah tahu dah kan, dah belajar kan. Yang lecehnya to determine group the anomalies come from group 2 and group 15. Itu yang masalahnya. Okay, so once we have determined that, it should be easier because we know the reason already. Okay, alright. So group 2, your answer should be you may draw it based on the energy orbital diagram, based on orbital diagram, or you may explain it in a sentence ataupun in a very short paragraph that should consist of all the keywords there. Okay, that you should have in a sentence. Okay, so the highlight would be based on R, okay, come from group 2. Group 2 have group 2 elements ataupun ataupun R, okay, R has a full-filled 2s orbital. Okay, sorry, a full-filled s orbital. Okay, R come from the orbitals for R, the s orbital for R has been fulfilled ataupun yang semaksud dengannya lah. Okay, nak menunjukkan that the s orbitals has already fulfilled. So if you want to remove an electron from a fulfilled orbital which is already stable, okay, more energy is required. Okay, alright. So maksudnya kalau you nak tunjuk, draw S. Okay, so you kata this is R. This is R orbital diagram ataupun partial orbital diagram. So this is fulfilled and it is stable. So if this is fulfilled and it is stable, more energy is needed to remove the electron. Okay, alright. And then you highlight the U. Okay, the U. Lupa. Kalau you nak highlight, this is fulfilled kan, and then it would be good if you could highlight the S. Okay, group 13 maksudnya dia macam ini. This is S, this is P kan. This is fulfilled and then we have one more. So this is unstable. Mana nak tulis ni? This is unstable because it is partially, sorry lah ya, buruk lah pula bersepah ni. Okay, this is partially stable. Comparison, you compare, okay? You compare. Partially filled. Kenapa? Why is it about partially filled? Okay, because it is unstable. Unstable means less energy needed to remove this electron. Okay, all right. So let's move on to group 15 and 16, which is
Madam.
Yes.
Sorry nak tanya, untuk yang ni kan kita tak tahu dia punya macam exact partial exact orbital diagram kan. So kalau yang ni kita tak perlu label lah kan, just S dengan P je lah, right, untuk show the difference between fulfilled orbital dengan partially filled orbital.
Yeah, betul. Okay, this is group 20. Okay, the first element. This is period 2 if I'm not mistaken. Ni period 2 ni sebab dia 20 elements kan. So that's why kalau you dah familiar with the periodic table, kan saya dah kata first 20 groups of element in the periodic table, okay, by right you kena hafal lah. Okay, kalau you tahu, that means it should be 2S lah, 2S and 2P. Okay, alright. Kalau tak tahu, that means you leave it as S and P. Okay, leave it as S and P. Okay, so this is group 2, group 2. Okay, this is group 2 and this is group 13. Label lah macam mana you nak label kan. Highlight kan, this is 2 and 13. Okay, you propernya, okay, this is R kan. R come from group 2. Okay, R come from group 2. So, R has a full-filled orbital S. Okay, R has a full-filled orbital S. A full-filled orbital means it is stable. Okay, a full-filled orbital S, that means the orbital is already stable. So, bila stable, more energy is needed to remove the electron. Settle. Okay, ni kena tambah lah dekat sini. More energy. Ini kita short form lah sebab this is just for our understanding. Okay, you may improve, okay, in terms of dia punya drawing, dia punya explanation. Okay, first IE is increase IE. Okay, alright. So group 15 pun sama. That means it is in terms of it is halfly filled. Okay, halfly filled. Macam mana nak buat halfly filled kat sini? Buat kat sini lah. So halfly filled for you would be, sebab dia group 15 kan. So we have S and P. So this is S, this is P. So S is already fulfilled. Now, okay, macam mana kita tahu ada 3? Sebab dia group 15. So 2 plus 3. It is equal to 5. So 5 valence electron belongs to group 15. Okay, alright. So this again label. This is half filled. Kenapa dengan half filled? Half filled is stable. That means more energy, more IE is needed to remove the electron. Whereas for V, draw lah balik. Okay, right. This is partially filled. Okay, partially filled kenapa? Dia unstable lah. Okay, partially. You have to highlight the partially filled dengan half filled tu. Okay, because partially filled is unstable. That means less energy is needed to remove the electron. Okay, to remove this electron. The first ionization energy. Okay, remember the first ionization energy. Okay, alright. So let's look at the answer here. So first IE of P is greater than 5. Tengok B. Element R and U are anomalous as the removal of its first electron is from a stable orbital. Okay, alright. So as you can see, it is very simple, but then again, it depends on the marks allocated for this question. Okay, alright. So you rasanya dulu kita kena highlight kan, the first electron is from a stable orbital. So define stable orbital because we have R dengan U. Okay, and then we have several types of stable orbital. What do you mean by stable? Okay, so you have to specify. Ataupun you mention R have a full filled orbital and U has a half filled orbital. Okay, so both of these are considered stable orbital. That means you have to, the energy will be higher, okay, in order to remove the electron from a stable orbital. Okay, alright. So yang saya bagi ni lebih complete lah, lebih detail. Okay, if you were asked to explain your reason, this is how you should explain. Okay, alright. Predict the first ionization energy of element P as compared to Q. Okay, ni kita nak kena predict whether P ni should have higher ionization energy than the Q, okay, ataupun it should be lower. Okay, jawapan you guys apa? Memanglah tahu dah nampak jawapan dekat sini kan, tapi jawapan yang you buat sendiri, you predict higher ke lower? Saja nak tahu. Okay, tak ada, tak salah, tak salah, tak betul, just nak tahu. How many of you predict that the ionization energy for P is higher than Q? How many? How many? Siapa yang boleh respon? Siapa yang tu cakap saya? Predict higher than Q? Anyone? Ada? Tak ada? Okay. Siapa yang predict lower than Q?
Saya.
Okay. Alright.
Saya.
Okay, ceramai je tu lower than Q Alright. Okay, so let's go through. Kita tak sempat lah nak tanya reason ikutkan saya nak tanya tapi kita tak sempat lagi. Just saya explain je lah. Okay. Alright, so let's look at the answer. The P, okay, the first IE of P should be greater. It should be greater, not lower. Okay, alright. Senang je nak come out dengan tu, senang, greater ataupun lower. But what is the reason behind this? Okay, remember the word consecutive atomic number. Okay, so P, Q, R, S, T, U, N. So obviously P, okay, kita boleh predict that P comes before the Q. Okay, tu satu dulu yang you kena tahu. And then kita clear dulu everything off from the slide. Okay, so P comes before the Q. And then kita nak tahu whether P ni they come from the same period ataupun they come from different period. Tadi kan kita dah determine 1, 2, 13, 14, 15, 16, 17, 18. That means dekat satu period tu dah settle starting from group 1 until group 18. Okay, that means P should come from a different period. Okay, so P should come from a different period. So kalau dia P comes before the Q, that means P come from the previous period. Okay, nampak tak hint dia dekat situ? P tak mungkin akan sama tak akan sama period dia with this element here. Dia tak mungkin akan sama because we have already determined dia ada 1 sampai 18 dah. Dah cukup. Okay, we have all the elements there starting from group 1 until group 18. That means P should not come from the same period as this element. Okay, that means P kena datang from different period. Okay, now it should be a previous period ataupun after period. Period after these elements. Dia kata consecutive kan? That means P should come from the previous period. Kalau P come from the previous period, okay, regardless lah. Katakanlah we have determined this one is n is equal to 2 kan? Ataupun even n is equal to 3 pun, doesn't matter lah, okay? So P should come from the previous period. So kalau kata saya letak n is equal to 1 ke ataupun kalau ni n is equal to 3, that means this should be n is equal to 2. That means previous lah period. Okay, alright, so once we have that, kita dah nampak dekat situ that the n is less than the n from all of this element. Okay, kalau dia has lower n, that means dia punya number of shell is lesser kan? Number of shell is lesser. Bila number of shell is lesser, apa yang kurang dekat situ?
Shielding effect. Yes,
shielding effect. And then the distance between the nucleus dengan the valence is now closer. Bila the more closer the valence dengan the nucleus, the stronger the attraction. Bila stronger the attraction, more energy is needed to remove the valence electron. Okay? Right. Faham ya? Okay, so that is why the answer should be greater than Q lah. Greater than Q. The answer is it should be greater than 520 kilojoules. So this belongs to Q. Kenapa? Because P come from another period. Okay, ataupun less less a quantum number, okay, less principal quantum number ataupun less n. That shows that the size of P is smaller than Q. Okay, dia punya key dia adalah less, dia punya n dia tu, P come from the previous period. Bila you tahu from the previous period, I mean the size is smaller. Bila size is smaller, attraction is stronger. That means it is harder ataupun difficult to remove an electron ataupun the valence electron. Harder means higher ionization energy. Kena highlight tu Sometimes student tahu harder to remove tapi ionization energy lower. Tu contradict Dia tahu harder tapi ionization energy jadi lower. So salah. Ionization energy should be higher. Okay? Faham ya? Okay. Any question related to this one? So saya rasa this is past years if I'm not mistaken. Ataupun past test. Okay? Lama-lama dulu. Okay, hope you get that. Okay. Next checkpoint, choose the element that has higher first ionization energy in the following pair given. Explain your answer. Okay, alright. So this is the normal trend. Okay, silicon dengan phosphorus. Just make sure, okay, the anomalies, okay, group 2 and group 15. Okay, so please be aware of that. Alert on the elements that come from group 2 and group 15. Okay, silicon. Does silicon come from group 2 or 15? No. Okay, but phosphorus, yes. Phosphorus come from group 15. Okay, but not silicon. Tapi still, this is 15, this is 14 kan? Tak apa, dia tak ada masalah. Dia bukan anomaly sebab dia follow trend. Okay, they still follow trend. Sebab comparison kita 15 and 16. 2 and 13. 2 tak follow trend because 13 dia punya ada deep in ionization energy. Okay, tapi if the question compares between 14 and 15, so there's no anomalies there. Tak ada anomalies. Dia normal. Okay, kalau 15 and 16, ada anomalies. Okay, alright, 14 and 15, so these two come from the same period. Okay, determine. Okay, so dia datang daripada same period. Macam mana tahu same period? Kena buatlah what we call that, the electron configuration. Okay, kena buatlah situ. Kalau tanya saya sekarang memanglah saya dah tahu. Okay, alright, so to be safe, just construct your electron configuration to be confirmed. Okay, so across the period, the ionization energy should be increased. Kenapa? The simplest would be based on period is based on Z effective. Okay, alright, so phosphorus should have higher ionization energy. The answer would be phosphorus phosphorus. Okay, because phosphorus has higher Z effective, which is equal to the Z effective is equal to positive 5. Whereas silicon has Z effective is equal to positive 4. That means phosphorus has higher ionization energy. Dia cakap first kan? Okay, highlightkan the first. Okay, please do not do pula. Saya nak guna do dengan use, campur jadi do's. Okay, please do not use arrow. Okay, this is for me, for lecturer. Okay, to simplify the nak cepatkan penggunaan perkataan nak tulis. Okay, so we use arrow. But in exam, okay, you are required to spell it. Okay, to spell the word, jangan pakai arrow-arrow ni. I mean, jangan pakai arrow untuk explain higher ataupun lower lah. So that's what I meant just now. Okay, right. Nitrogen and oxygen. Okay. This is group 15. This is group 16. This is what we call anomalies. Okay, so this is anomalies. So the best is to explain using orbital diagram. Okay, show the orbital diagram. Okay, boron and beryllium, this is also anomalies. Okay, because this is group 13, this is group 2. So you have to mention in terms of orbital diagram. Stability. Orbital stability. Okay? Alright. So draw. Saya advise awak untuk draw and then compare. Okay? And then label. Okay? Alright. Dah banyak
Madam,
kali dah tunjuk sebelum ni so saya tak tunjuk lah. Saya explain saja. Yes.
kalau yang untuk A tu kan, kalau kita tengok dekat dia punya orbital diagram kan, yang P tu dia half fill kan, phosphorus tu.
Ya, half fill.
Kalau yang silicon tu dia macam partially fill je kan. So kalau kita cerita dari segi stability tu boleh ke? Maksudnya P has the first ionization energy because the electron was removed from the stable orbital diagram, which is the half fill. Boleh ke?
Boleh tapi tak dapat markah penuh lah kat situ sebab highlight dia punya highlight because this yang untuk A ni, okay, the A ni dia follow the trends. So bila dia follow the trends, apa trend yang we use, what is the reason that we use to explain the trends? It's because of the Z effective, right? Okay, boleh you may use the orbital diagram but that is not the highlight. Okay, but you to be safe have the Z effective and also the what we call that the orbital stability. Okay? Ada dua-dua lagi bagus. Tapi kalau you ada the orbital stability, saya takut the mark will be minus lah because the highlight for A is not so much on the orbital stability. Without the orbital stability pun, okay, dia still akan tinggi. Kenapa? Sebab dia follow trend because of the Z effective. Faham tak? Sebab dia follow trend. Kalau you tak ada mention in terms of orbital stability pun dia still akan tinggi. Itu maksud saya. Okay? So know what to highlight. So B dengan C kita kena highlight in terms of orbital stability. Kenapa? Because we compare 15 dengan 16. Even though the Z effective for oxygen is higher than nitrogen, so nampak ada contra effect dekat situ. Supposedly oxygen should have higher ionization energy. Kenapa? Because the Z effective is higher. Tapi it's the other way around. Kenapa? Because of the orbital stability. Okay? Tapi untuk A, phosphorus has higher Z effective compared to silicon, betul tak? Phosphorus has higher Z effective compared to silicon, and that explains why phosphorus has higher ionization energy. Okay, and plus the orbital stability lagilah tinggi kan? Tapi the highlight would be Z effective lah. Okay, kalau if you were to include the orbital stability, go ahead, but please make sure that you have the Z effective. Okay, that's why kita belajar kena ikut trend dulu and then baru ada anomalies. Okay, trend tu dia based on apa? Z effective. But when we have anomalies, kita kena not only we have to consider the Z effective, we have to consider the orbital stability as well. Okay, right? Faham Okay.
Faham, madam.
Pusing. Okay, so see, nampak tak? You have to highlight the Z effective because dia follow trend kan? Dia follow trend. Okay, across the period. But nitrogen dengan oxygen dia tak follow trend. By right, this is positive 5, this is positive 6. Tapi why is it nitrogen has higher first IE compared to oxygen? Okay, same goes to beryllium. Beryllium is positive 2. The Z effective is positive 2. Boron is positive 3. Tapi kenapa beryllium has higher first IE than boron? Okay, alright. So highlight. Okay, the electron in N is being removed from a half filled to p orbital, giving more stability on the electron. Hence, more energy will be required to remove one of them. Okay, or you may use the orbital diagram. Okay, simple. Orbital diagram, draw and then label. That's all. Okay, and then conclude. Okay, this is half filled. Mesti ada the word half filled tu, and then we have fully filled. Okay, mesti ada that word because itu satu markah there. Okay, moving on. Okay, next question. The graph shows the trend of the first ionization energies of some elements in period 2 and 3 with consecutive atomic numbers below 20. Okay, choose one element that, okay, so A has the tendency to form an ion with charge -1. Okay, alright. So before we could answer this question, kita kena predict dulu the group that these elements belongs to. Kita kena predict dulu so that senang kita nak jawab. Okay, alright. So remember, that's why anomalies is very important. Okay, it gives us hint, dia indicate something dekat situ. So you should be aware of anomalies. Okay. Alright, dekat sini kita nampak ada dip dekat situ kan, ada penurunan dekat situ. This is ionization energy, okay? Alright, this is very sudden dip dekat sini. Okay, maksudnya kita ada elements These are all elements, bukan elektron. Elektron dibuang satu-satu bukan itu So ini different elements. Okay. And then A, and then B, and then C, D. Maksudnya dia increasing dekat situ. Okay. Remember kita ada anomalies group 2 and group 13 and 15 and 16. Okay, so this is very unlikely, okay, to be group 2. Okay, ni bukan group 2, ni bukan group 13. Sebab dia dah sampai peak dekat situ and then dia starting from here, dia start dekat sini. Nampak, dia saja tunjuk ada satu elemen dekat sini. That means kita ada dekat bawah tu ada lagi. Okay, dia ada lagi ke situ. So this is most likely group 15. A come from group 15, B come from group 16. Okay, 16, and then this is 17, this is 18. Okay, alright. So 2 and 13 bukan lah. Okay, so we have 15 and 16. Alright, so 15, 16, 17, 18. So ini 14 lah. Okay, consecutive, berturutan. Okay, if this is 18, that means 18, okay, dia drop. Nampak tak? Dia sudden drop. Okay, this is already 18. Maksudnya dah period tu dah habis dah sampai 18. That means kita akan start over lah. This should be group 1, okay, group 2, this is group 13. So dekat sini dah nampak dia ada nampak tak, dia tak follow trend. So this is also anomalies but from different period. Katakanlah this is n is equal to 4 lah. This is n is equal to 3. Okay, alright. So once we have that already, barulah senang kita nak predict jawapan-jawapan yang seterus ke bawah tu. Okay, alright. Soalan pertama, period 2 and period 3. Okay, salah. So dia dah cakap dah kat situ, tak perasan. Baca betul-betul. Okay, period 2 and period 3. Consecutive. Okay, alright, berturutan. Okay, so we have that already. Has the tendency to form an ion with charge -1. Apa jawapan dia, guys? What will be the answer for A?
C.
Yep.
C.
Okay, the answer would be C. Yang dia assign the alphabet lah. Okay, yang dia tak assign sebagai alphabet tu kita just ignore. Okay, so the answer would be C. Sebab group 17, okay, group 17 has higher tendency to accept one electron in order to become octet ataupun to achieve the stable electron configuration. Okay, so the answer would be C. B is choose one element that that is an atom with half-filled p electron. Okay, what will be the answer for this, guys? Half-filled p electron. So this is the trend for group
A.
Okay. Okay, so the answer would be A because this is the trend for group 15. Okay, 15 je yang ada half filled. Group 2 dia full filled, the rest are all partially filled. Okay, element that is very unreactive, what will be the answer for this?
D.
Okay, kan nampak tak? Dia senang bila you dah settle for apa nama tu, the group number, the valence electron. Okay, alright, so the answer will be D, and then D has anomaly in its first ionization energy. Anomaly.
15, 16,
B and E.
30. Yeah.
Sorry,
B and
the
E.
answer?
AB.
B and E.
A and E. Are you sure E?
E. B and E.
D. A and E, is it?
AB.
B and E.
A and B. Okay, sorry. A and B, yes. A and B. Okay, so kalau dia cakap has anomaly, suppose
Madam, kenapa bukan
lah.
B dengan E?
B dengan
E.
E. B tak problem. Yang problem A tu. Yang problem, okay. 15, 16, group, kan tadi group 2 dengan 13, betul tak? Anomalies dia 15 dengan 16. Yang problem siapa sebenarnya? Yang problem ni. Dia tak follow trend. Orang ni memang ikut dah, dia follow trend macam tu. Yang tak follow trend siapa ni? 2 dengan 15. Sebab apa? Because of the orbital filling, the electron filling in the orbitals in terms of the stability. Okay, so it's because of dia due to group 2 and 15, bukan group 13, 16. 13 dengan 16 tu dia memang macam tu because of the partial orbital kan, partially filled orbital. Tapi group 2 ni kebetulan dia cantik pula, dia punya orbital dia tu, dia full filled dengan halfly filled. Okay, so yang problem ni group 2 dengan 15. Tapi bila kita compare, kita kena compare 2 dengan 13. Kita tak boleh compare 1 and 2. 14 dengan 15, we cannot compare in terms of that. Kalau kita compare 1 and 2 ataupun 14 and 15, dia follow trend. Okay, kalau 1 and 2 ataupun 14 and 15, ini dia follow trend. Sebab 2 is higher than 1 in terms of ionization energy. 15 is higher than 14. Still follow the trend. Tapi dia tak follow trend bila when we compare 2 and 13, 15 and 16. So that is what we call anomalies dekat situ. Okay, that's why bila kita kena highlight tu, kita kena highlight A dengan B. Kalau kita highlight A dengan katalah this is Z kan, A dengan Z, there's no anomalies dekat situ. Tidak ada anomalies. Dia follow the normal trend. Okay, alright. Betul ke jawapan dia? So jawapan dia A saja. As anomaly in its first ionization energy. See? The answer is A. Okay, alright. Yang buat hal 2 dengan 50. Okay, alright. E is a member of group 13. Siapa yang datang daripada group 13? The answer is yes, E. Okay. So the rest will be easier lah once you have determined the group number of each of the elements. Okay, alright. So ini style different element from different group. Yes, different element from different group. Ada style, remember yang successive ionization energy tu, they remove electron satu from one element. Okay, they start to remove electrons starting from the valence, remove one by one, okay, until they reach the core electron. Okay, itu style lain pula. Okay, tapi we expect that the ionization energy should be higher as more electron has been removed. Okay, soalan ni lain dengan soalan yang itu. So don't get confused. Okay. Alright, so we have one more question. This one has been discussed previously kan? Dah discuss kan checkpoint 17 last time? Guys? Rasa kita dah discuss this one. Okay, predict the group, identify element A and justify your answer. So A come from group 15. Betul tak? So the ends kat sini because we have sudden increase in ionization energy. Okay, so A come from group 15 sebab 15 adalah IE5 indicates that the 5 electrons have been removed from the valence electron. Okay, because there is a sudden jump for IE6. That shows that the electron has been removed from the core electron. This is the core electron already ataupun inner electron. Electron yang duduk pada end, lower end. Okay, kenapa? Because the attraction is stronger. Okay, alright. So write the electron configuration of element A. So we know that A come from group 15. That means it has 5 valence electron. So this is very important. Once you have determined the group number, that means you know the number of valence electrons. There are 5 valence electrons. So how do we write the electron configuration? So we need the period. Kita perlukan period. Okay, tak, kita tak tahu di n dekat n equal to berapa. Sebab group 15 kita ada ke bawah tu ada banyak group, ada banyak elements there kan. So it is mentioned in the question located in period 3. Okay, so 1s2, 2s2, 2p3, 2p6, sorry, 2p6, 3s2, 3p3. Jangan 3p5 lah. Faham tak? It should be 3p3 because 3 plus 2 is equal to 5 valence electron. Janganlah p short pula 3p5. Kalau 3p5, 5 tambah 2 jadi 7. And then dia patutnya datang daripada group 17, which is salah. Okay, so sebenarnya topik tu ni dia banyak hint. Cuma you kena slow and be careful. Okay, kadang-kadang student dia dah shock dah. Oh, aku dah tahu lah 5 valence electron. So dia akan jadi 3p5. Salah lah. Okay, bertenang. Okay, so 3 plus 2 is equal to 5 valence electron. Okay, alright. Ada soalan ke tadi kat sini? Identify element A and justify your answer. Yang ni lah tadi okay. The largest increase occurs after IE5. You kena highlightkan the core electron, the inner electron. Highlightkan, that one will be 1 mark for that one. Okay. Okay. Banyak pula soalan Choose the smaller first ionization energy between oxygen and sulfur. Explain your answer. Okay, so this we have talked about this so many times. So we have oxygen and sulfur. Please remember the trend and anomalies. So oxygen and sulfur, they come from the same period the same group. Okay, both of them come from the same group. The group 16. Maksudnya ini going down the group. Okay, bila going down the group, the ionization energy is lower. They become lower, they decrease. Why is that so? Because of the increase in N. And because of the increase in N, the size become larger, betul tak? The shielding effect, the size become larger. That means the attraction is now weaker. Okay? So that's why the IE is lower for sulfur. Okay, lower for sulfur because they're going down the group. The N increase, the size increases. Okay, size increases, the attraction become weaker. Therefore, lower ionization energy, smaller ionization energy. Okay, choose the higher second ionization. Okay, higher second ionization. Second pula guys, second ionization energy between lithium and beryllium. Okay, ini kena bertenang. Okay, so be calm. This is not like what we have for the general trend yang kita selalu ada tu. Okay, because we are talking about second ionization energy. Okay, second removal dekat situ. So kita kena look at the orbital. Okay, orbital diagram lah. Okay, so lithium, we know that lithium come from group 1 kan. So the partial orbital diagram would be macam ini. Okay, this is beryllium. The partial orbital diagram is like this. Okay, group 2, this is group 2, this is group 1. Okay, bila lithium remove one of its electron, okay, becoming so dia akan jadi okay, alright, so dia remove dekat situ, ini buang, Okay, so 2s akan jadi kosong. Okay, alright. So ini this will be easier compared to 2s. Okay, this will be easier to remove compared s to s. So later dia akan jadi, yep, this is lithium. This is beryllium plus. This is lithium plus. Okay, nampak tak comparison? So we have no electron into s orbital, and for beryllium we have 1 electron left. Okay, alright. So the first ionization energy for beryllium is higher. Okay, alright. So now how about the second ionization energy? Okay, so kita kena consider kat sini 2s dah kosong. That means the second electron need to be removed from the inner n. N is equal to 1. Okay, which is 1s. Betul tak? Lithium period 2 kan? Okay. Kita dah nak kena buang dekat sini. Ni sebenarnya kita ada 1s dekat situ. Okay, alright. So kita ada 1s dekat situ. Ni dah kena buang lah ni. Kalau saya tambah lah dekat sini okay. Kita letak lah sebab after all dia punya tu sikit je. This is the orbital diagram for lithium and beryllium. Full orbital diagram. Okay, alright. So ni, okay, dia akan jadi lithium 2 plus. Okay, alright. So now the electron is being removed from the inner n. This is inner n yang dalam. So because the n is equal to 2 is already empty. Dah tak ada electron nak buang. So kena buang electron paling dalam. The next n lah. The next n will be n is equal to 1. Okay, for lithium. But for beryllium plus, lithium plus for beryllium plus, dia ada satu elektron lagi dekat n is equal to 2. Okay, which is n is equal to 2 is far from the nucleus compared to n is equal to 1. So kita predict that lithium 2 plus would have higher energy. Okay, so ini kalau nak buang ni, nak keluarkan will require very high energy. Because kenapa? The electron is now being removed from the inner shell. This is what we call inner shell. This is inner electron. Kenapa dengan inner electron ni? Because it closer to the nucleus. Closer to the nucleus means the attraction is stronger. Stronger means you will need energy to overcome that attraction. Okay, so lagi kuat attraction, lagi susah lah nak remove. That's why lithium 2 plus has higher energy, second ionization energy compared to beryllium plus. Okay, beryllium 2 plus, beryllium 2 plus. Okay, ini dia akan jadi begini. So ini akan keluar lah. This one will be removed. So dia akan jadi 1s. Okay, so this is beryllium 2 plus. This is lithium 2 plus. Okay, so dia akan jadi begini. Faham ke? Faham lah kat situ kena highlight the inner electron there. Okay, right. So using orbital diagram, it will be easier to explain. Okay, right. Oxygen, they have the same valence electron configuration, but the 3p shielding in sulfur is farther from the nucleus and experience less Z effective than the 2p electron. Tak payah mention Z effective, down the group. Okay, they come from the same group kan? So kenapa dia experience less Z? Okay, because of the N lah. Okay, it's because of the N. Even though they have the same Z effective, tapi sebenarnya the Z effective is decreasing sebab dia ada issue size dekat situ. Okay, the size become larger. That's why the highlight would not be the Z effective. It would be the increase in N. Okay, and the increase in N have a smaller first ionization energy. Further, down the group, the size become larger. Okay, right. Ni yang tadilah nak cakap tadi. Okay, this one dia mention in terms of electron configuration. Tapi saya siap tunjuk the orbital diagram. Okay, alright. So 1s2. So the more electron being removed, especially from the inner orbital, okay, from the inner orbitals, that means the lithium plus becoming lithium. Kenapa dia jadi 2s2 dekat sini? Terbalik je ni kot. Ya betul. Betul 1s2. Tapi ni kenapa 2s2? Lithium come from group. Betul tak guys? Kenapa
Lithium
2s2?
group 1.
This is 1s2. This is for lithium plus. Okay, this is correct. Okay, maksudnya one of the electron has been removed from 2s1. Dia ada sebenarnya kalau lithium dia 1s2, 2s1 kan. So once this one has been removed, dah keluar dia become lithium plus.
Madam, yang ni dia macam accept je.
Terbalik madam, terbalik.
Dia accept ni. Dia accept electron.
So lithium jadi lithium 2 plus. Kalau dia jadi lithium 2 plus, that means dia jadi 1s2. Okay, it should be 1s2 dekat sini.
Terbalik dekat bawah tu.
Tapi ni betul lah ni, 1s2, 2s1. Kan? Betul lah ini salah. Okay. Because one shield more effectively than they shield each other, we predict that it should be to remove. Okay, shield. Maksudnya dia banyak elektron lah. So beryllium has more electron than beryllium 2 plus has more electron than lithium 2 plus. Okay.
Madam, yang ni dia tak emphasize pun pasal inner electron.
Tak, dia memang tak emphasize. Sepatutnya dia kena emphasize because you kat sini dia cakap sini shield. Okay, shield maksudnya you have dia mention in terms of beryllium 2 plus has more electron than lithium 2 plus. Okay, ataupun you may shield maksudnya dia n is equal to 2 dekat situ. Yang this one n is equal to 1. This is already n is equal to 1. Okay, that means dekat sini n is equal to 2. Kalau dia masih n is equal to 2, maksudnya shielding dia banyak, betul tak? Shielding effect dia still tinggi because the n is equal to 2. Now n is equal to 1.
Madam, kenapa n equal to 2 untuk beryllium 2 plus tu?
Tadi ni
Kenapa dia tak jadi 1 juga?
nampak tak ni saya tunjuk ni? 1s2, okay, beryllium plus, okay, dia nak buang elektron kan? Sebab this one dia being removed to n is equal to s. Nampak tak?
Yang ni bukan untuk yang first ionization energy ke madam?
Ni first ionization energy yang ni dia buang daripada 2s. Nampak? So dia jadi apa? Dia tinggal satu elektron je tinggal, betul tak? And then this is already beryllium plus. Nak buang lagi satu elektron, dia kena buang dekat mana? This one, betul? From the 2s. Tapi kalau lithium plus tadi nak buang satu lagi elektron, dia kena buang dekat mana? 1s. Pada n is equal to 1s ni. Nampak tak? This is already inner shell. Ini dah inner shell. Ini belum inner lagi. Dia masih buang dekat 2s sebab tadi dah buang. Okay, this is the first electron being removed kan? Betul tak? Dia jadi beryllium plus. Now the second electron nak kena remove, nak buang yang mana? Daripada 2s lah sebab dia dah single kan tadi pakai color lain lah pula. Okay. Ini second electron nak kena keluar. Second electron. Dia keluar daripada 2s. Okay. Tapi lithium plus ni, okay, the second electron nak kena keluarkan, dia dah kena buang daripada n is equal to 1. Okay, dia dah kena keluarkan pada n is equal to 1. Logically speaking, kalau n is equal to 1 is already dia yang paling nearest to the nucleus. This is inner shell already. Diorang punya valence adalah n is equal to 2, betul tak? So inner diorang n is equal to 1. Bila lithium plus buang lagi satu elektron, dia dah kena start buang daripada core dekat situ. Dah buang daripada inner shell. Tapi beryllium plus, bila buang lagi satu elektron, still kena buang dekat N is equal to 2 dekat situ. Faham tak? Faham tak?
Faham, madam. Faham.
Okay. So bila you draw, baru you nampak. Orbital diagram is the best. Okay, for you to see clearly in terms of the orbitals, stability. You boleh nampak everything. You boleh keluar step by step. Tapi kalau you use this one, that's the thing. Bila you pakai ni, boleh, tak ada masalah. Kalau you dah pro enough, you may use this electron configuration. Okay, in fact sampai sekarang pun saya to be safe, saya suka nak tengok in terms of orbital diagram. Sometimes kita tak nampak using the electron configuration. Okay? Yep.
Madam.
Yep.
So, nanti kalau contoh kita explain macam buat orbital diagram yang tadi pun boleh lah kan?
Boleh. Itu lebih better. Tapi if you use orbital diagram, you kena label lah. Make sure that you label nicely, okay? Label all required. Maksudnya, okay, this is N is equal to 1, okay? You kena tunjuk label lah. This is already inner shell. Ataupun this is core electron. Yang ni kan? You boleh cakap juga. These two is core electron. This is not core. Ini still valence because the N is equal to 2. This one N is equal to 1. Okay? Label apa yang perlu dilabelkan. Maksudnya kita nak highlightkan the lithium ni, okay, the second electron is now being removed from the inner shell. Ataupun the core electron sekarang ni, inner electron has been removed. That's why the ionization energy, the second ionization energy for lithium is higher than beryllium. Okay? Right. Okay. Ayo. Okay. Alright. Any question related to that? Okay, last question. Rasanya ni last question ku. Last question rasa saya nak berhenti kat sini juga. Okay. Right. Equation representing the following process. Okay, the third ionization energy of iron. See, the third ionization of iron. Okay, so please be careful, buat step by step. Okay, alright. So katakanlah kita start from the beginning lah. Okay, kalau you tak pro lagi, you kena start from the beginning. Kalau you dah pro, you tahu. Kalau you dah pro, senang aja. Okay, kita buat style orang pro kan. Third ionization energy, that means dia should be removed from 2+. Third, that means dia punya product will become Fe3+. Okay, third ionization energy, that means the product should be Fe3+. Okay, and then dia buang elektron kan, so dia buang elektron, that means it need to be removed from Fe2+. Okay, alright, so remove electron, dia jadi Fe3+. Don't forget the state, guys. Wajib, tak ada state salah. Okay, alright, so we transfer this to the other side, it becomes Fe3+ gas plus electron. Okay, so this is third ionization energy.
Madam, yang first equation tu kalau tak buat tak apa ke? Kita terus yang
tak payah. Ni tak payah buat saja je, saya nak tunjuk awak.
Okay.
Tak payah. Okay, alright, ini dia punya tu. Maksudnya you nampak dia kata third ionization energy, that means your product should have Fe3+ and the starting material ataupun starting species should be Fe2+ in gas state. Okay, so we are talking about ionization energy, that means the electron has being removed from the ion. So you kena remove, maksudnya it should be on the right hand side. The electron should be the product. Okay, yalah, bila buang electron is one of the product. You remove electron. So ini product dia, ion and also one electron. Okay, alright. Kalau tak biasa, that means you kena start from the beginning. Okay, Fe in gas state, okay, buang elektron, dia akan jadi Fe2+, gas, Pl2+ lah, plus, okay, tambah elektron. So this is the first IE. And the second IE, kita ambil this one, Fe plus in gas state, jadi Fe2+ in gas state plus electron. Nampak elektron dia satu-satu. This is second IE. And the third IE, jadikan this as the reactant. So Fe2 plus in gas state becoming Fe3 plus in gas state plus electron. So this is the third IE. Okay, yang ni yang kita nak. Okay, alright. The electron affinity of fluorine. So as you can see, dia tak specify whether the second electron affinity, third or so on. Okay, that means we can just assume this is the first electron affinity for fluorine. Okay, alright. So first electron affinity is not a problem, tak ada masalah sangat. That means first step tu, that will be the equation lah. Okay, for fluorine. Okay, fluorine dia cakap fluorine dekat situ, that means electron affinity means accepts electron. Okay, this is the opposite of ionization energy. So fluorine, okay, in gas state, wajib mesti ada gas plus 1 electron becoming F minus in gas state. Okay, alright, so this is first EA of fluorine. Okay, alright. C, the first ionization energy of boron. Alamak, yang ni kita dah buat third ionization energy, apalah masalah lagi kalau first ionization for boron. Okay, this is B and this is C. Okay, so boron, so the product will be first lah, positive 1. Okay, remove electron, so remove, dia akan pindah to the other side, dia akan jadi B plus gas plus electron. Okay, this is the first IE for boron. Okay, alright. So the electron affinity of O minus. Okay, dia dah mention O minus dekat situ. Ada dua cara dia nak explain this. Okay, the second electron affinity of oxygen. Okay, and the electron affinity of O minus. Dia punya equation will be the same. Cara dia cakap, cara dia sampaikan tu berbeza, but the answer ataupun the equation will be the same. Faham ya? Alright, so macam ni dia cakap the electron affinity EA for fluorine. That means your starting reactant will be fluorine atom, not fluorine ion, fluorine -1, fluorine -2 and so on. Okay, so it should be fluorine atom in gas state. Okay, so for D, electron affinity for O minus. O minus, second electron affinity for oxygen sebenarnya. Second is the same, second electron affinity of oxygen atom. Ini benda yang sama. Okay. Alright, so kita O minus kan, kita start with O minus in gas state plus electron becoming O2 minus in gas state. Okay, so this is the EA of O minus lah. Okay, as you can see, all the electrons are for each of the chemical equation, semuanya satu. Okay, dia step by step process, stepwise process, right? Nampak ke dia punya kat sini? Ya betul. Betul tak? Ya betul. Okay, alright, that's all guys. Ada lagi ke? La ilaha illallah. Location of the alkaline earth metal in the periodic table is shown below. Explain why their electron affinities are either positive or small negative values. Okay, remember EA also have anomalies. Okay, this is again due to stability. Okay, group 2A ataupun group 2 dia dah achieve fulfilled orbital. It's already fulfilled. Electron affinity maksudnya to accept electron. So that means the electron accepted later, if this element need to accept electron, the incoming electron will need to be put ataupun to be placed in the higher sublevel. Katakanlah this is 2s. Okay, so dia kena masuk dekat 2p. Remember, 2p, 2s, 2p has higher energy than 2s. So bila elektron nak kena masuk pada new sub-level having higher energy tau. This 2p has higher energy. The orbital has higher energy. Okay, so nak letakkan elektron dalam orbital having higher energy ni, you would require energy rather than releasing the energy. Okay, that's why dia punya, kenapa dia kata explain why their electron affinities either positive or small negative values. Okay, so dia tak prefer lah accepting the electron, because kalau you nak accept, you still want to accept the electron, that means you have to have extra energy, because the electron will need to be placed in the higher sub-level. Okay, in the higher sub-level. That's why dia kata positif ataupun small negative. Okay, normally bila dia accept electron, dia akan release energy, because starting from here kan, bila dia accept electron, dia become lower. But not for group 2 to A. Group 2, group 2, okay, group 2 ataupun group 2A. Okay, so that's the reason why dekat situ. See, because added electron goes into higher energy level or sub-level which is less stable. So as you can see, this is partially filled. Partially filled is unstable. Dah lah requires energy. Lepas tu tak stable, okay, so that is very unlikely for group 2. Okay, dia tak favor accepts electron. Okay, alright. Yeah, that's all for topic 2. Finally, ya Allah, habislah masa kita. Okay, remember kita ada additional class on Wednesday. Every time kita macam ni, kita kena buat additional class. Okay, alright, so let's take a break like 3 minutes before we proceed to topic 3. Okay, alright. Any question? Lupa nak tanya.
Kita boleh tengok balik slide sebelum ni.
Mana? This one?
Ya. Madam. Hello.
Saya.
Lah, madam ke? Madam.
Yep.
Untuk yang apa tadi tu? First ionization energy untuk boron kan, kan kita kena ada dia punya state of matter kan, which is gas kan, tapi bukan ke boron supposedly dia solid dekat room temperature?
Because the reaction is not conducted at room temperature. Okay, that's why ionization energy, in order to perform ionization energy tu, it need to be in gaseous state lah. That means all the solid state punya elements, they need to be converted into gas first. Okay, so this is not what we call experiment conducted at room temperature ataupun at normal temperature. Dia adalah extreme reaction. Okay, so this electron affinity and ionization energies, okay, ini adalah reaction yang kita conduct with very extreme conditions. Everything need to be in gas state. Okay, kita kena make sure dia vaporize dulu, then only we can perform we can remove the electron, we can force the electron to be added into the atom. Okay, dia bukan normal punya condition lah.
Okay, madam. Thank you.
Alright, okay Alright, any questions so far? Okay.
Madam,
Yup.
kalau macam M tu dia capai -3, dia jadi stable ke? Sebab P tu sudah full kan, fulfill.
Come again, lagi sekali.
Kalau M tu sudah M-3, dia sudah stable ke?
N-3.
Yang
Talking about nitrogen, is it?
alkaline earth ni.
Alkaline earth. Okay. If N is the principal quantum number tu.
Kalau macam M tu sudah capai third ionization affinity, electron affinity, jadi M-3 kan. So dia kan half filled sudah p orbital. Jadi maksudnya dia stable lah.
Dia stable lah as long as dia achieve the what we call that the electron configuration of the noble gas. Dia dah achieve that, dia become stable lah. But is it kita kena look into dia punya values of electron affinity itself. Okay, is it as simple as kita just cakap okay dia accept 3 electrons and dia become stable kan? Adakah dia semudah itu?
Okay.
Because you for group 2 ke group siapa? Group 2 perlukan 6 lagi elektron tau. Maksudnya group 2 in order to achieve the electronic configuration of noble gases, okay, it requires 6 more electron to be added into the p orbital. Betul tak?
Madam.
So 6 elektron tu, perlukan 6 elektron tu, don't forget dia ada shielding effect kat situ. So the more electron is added, that means the shielding effect will be higher. So when you add, macam nampak macam masukkan je kan. Tapi dia susah, dia it's not as easy as that. Maksudnya we have to consider the repulsion, the shielding, okay, and then the energy itself is the sub level energy. For example, 2S dengan 2P nampak macam N sama dengan, sebab kita draw tu macam ni tau. That's the thing. Bila kita draw macam ni, kita nampak that 2S and 2P tu they have the same energy. Sebenarnya sepatutnya kita kena draw macam ni. Tengok afbau. Okay, tapi untuk simplification, untuk kita nak simplify kita punya tu, kita tahulah maksudnya 2S come first, that means 2S has lower energy than 2P. But in terms of this, dia tak represent lah. Okay, dia tak represent the energy. Yang represent the energy, 2S come first, that means 2S has lower energy than the 2P. Okay, so imagine kalau this is magnesium, okay, so magnesium bukan 3S, 3P lah. Okay, 3S, 3P. So this is magnesium. So kalau dia nak achieve like, dia nak jadi macam siapa? Argon. Dia nak jadi macam argon kan? Okay, dia can either become like argon ataupun neon. So katakanlah dia accept electron in order to become argon. So as you can see, berapa banyak number of electron dia kena accept in order to become argon. Okay, ada 6 elektron dia kena accept in order to become like argon guys tu. So boleh lah kita push tapi energy will be higher lah.
Kalau 3 je madam, 3
tak jadilah macam argon. Okay, tapi dia adalah that half fill tu kan yang you kata half fill kan, tapi still it's not as simple as that lah, because when more electron is added, that means the repulsion is, you have to consider the repulsion, the shielding effect lah. Okay?
Madam,
Yup.
kan kat situ dia cakap less stable tu kan, tu maksudnya elemen selepas add elektron lah kan?
Ya, once dia M, dia jadi M plus, M minus for example kat sini kan.
Kalau saya cakap pasal elemen before add elektron tu, grade stability boleh ke?
Maksudnya instead of highlighting this one, you highlight the reactant. Boleh lah, sama lah maksud dia. Okay, tapi
boleh.
tak payah don't go for grade, okay, just go for grade without the grade lah, maksudnya have more ataupun more stable than the product ataupun M- ke apa in this case kan. Jangan use the word grade lah, grade. Okay, ataupun
Okay, madam.
better stability ataupun more stable ke gitu. Kalau greater ni usually kita kita go for something yang betul-betul stable. Contohnya half fill dengan partially fill, full fill dengan partially fill, ataupun noble gases punya electron configuration. Great stability and the best. Okay?
Okay, madam.
Right. Okay, saya nak cuci tangan sekejap.
Hi, madam.
Alright, okay. Walaupun kita lambat, tak apalah. Okay, Alhamdulillah. So we are done with topic 2. Now let's move on to topic 3. Okay, so topic 3, like I said earlier, okay, before we start our semester last time, I have mentioned that topic 3 is one of the most challenging topic, okay, of all the topics that we have in semester 1. Okay, so please be prepared. Okay, one good thing about topic 3, it does not involve any calculation. Okay, just a concept that we would like to introduce to you. So this concept might be new to you. Dia baru, that's why most of the students, the previous batch student kata dia adalah challenging. But once you have understand ataupun you have learned the concept and you dah faham, dia senang saja. Okay, it's like topic 2 kan. So you dah ada that concept, it will be easier for you to understand the especially in terms of question asked in the exam. Okay, so you dah tahu apa yang dia nak. Okay, alright, so moving on, topic 3, Bismillahirrahmanirrahim, chemical bonding. Okay, alright, so topic 1, you have been introduced to elements, okay, how to name the elements, how to write the chemical formula, okay, how to calculate when you are given masses, molarity and so on. And then topic 2, you know how the atoms ataupun the elements behave in the periodic table, okay, the characteristics, the properties across a period and down the group, and then we have anomalies. Okay, so those are topic 2. Then next will be topic 3. Okay, so in topic 3, we want to highlight the chemical bonding, specifically for bonding. So elements in the periodic table, okay, kita ada elements in the periodic table. How do they behave in chemical bonding? Okay, how do the bonds form between the elements? Okay, so kita nak study in detail. So maybe in during your SPM time, you have been introduced to some basics chemical bonding. So we have ionic and covalent kan, and how do they form. Okay, so in this topic, we are going to learn that, okay, but in detail. Okay, sedikit dalam sedikit. Okay, right. Topic 3, chemical bonding. So these are the content, the subtopics that will be covered in this topic 3. Okay, all right. So we're gonna start with Lewis dot symbol. Okay, 3.1. So we have 2 LO for this one. Okay, right. Valence electron and Lewis dot symbol. So Lewis dot symbol, or a Lewis electron dot symbol, is a symbol in which the valence electron of an atom or ion are represented by dots around the chemical symbols of the elements. Okay, so how do we represent the elements with their respective valence electron? Why do we need valence electron? Kan ada banyak lagi electron, because these valence electron are the one involved during the bonding. So core electron dekat inner shell tu, those will not be involved in the bonding. Tak ada. So that's why yang paling penting adalah valence. Is either remove, is either kita accept electron pun will be added dekat valence shell, ataupun during the sharing pun it only involve valence electron. Okay, that's why valence electron is very important. So how do we represent the elements with their valence electron? So we use Lewis electron dot symbol. So Lewis is the scientist that who discovered this method. Okay, so for example, lithium come from group 1 kan? Alright, so maksudnya kita ada 1 dot dekat lithium symbol tu. Beryllium come from group 2. Okay, so it has 2 valence electrons. So we have 2 dots. Okay, 2 dots for for beryllium symbol. Okay, alright. Boron has 3. That means we have 3 dots. So imagine dia adalah kotak. So kita hanya gunakan sisi dia saja. All the sides. Jangan guna bucu-bucu ni. Bucu jangan guna. Bucu dilarang. Okay, bucu tak boleh. So you have to use all the sides. So we have 4 sides sahaja. Okay, alright. So carbon we have 4 valence electron. That means we use all the 4 sides of carbon. And then nitrogen. Okay, nitrogen we have 5 electron. That means the electron need to be paired up. Dia kena dipairkan, dipasangkan dekat situ. Sebab after all we only have 4 sides. Okay, so dah kena start pasangkan lah. Dia macam orbital diagram kat situ.
Madam, ada certain orientation ke yang kita kena ikut untuk pasangkan dia ni? Which means mana side yang start dulu tak kisahlah.
Tak ada, cuma dia kena single dulu, then only they start to pairing up. Okay, tapi dia nak pasangkan dekat mana ke, kat sini dulu ke kat sini, doesn't matter, tak kisah. Okay, so as long as once all of the sides has been used, maksudnya kita dah place all the electron ataupun all the dots dekat sides tu, baru you start pairing up. Jangan buat macam ni. Nitrogen, you buat macam ni kan. 1, 2, 3, 4, 5. Don't do this. Okay, and then sini kosong. Jangan buat macam ni. Don't do this. Maksudnya dia kena, all the sides tu must be placed with electron. Then only dia start pairing up. Macam Hans kan, Hans cakap macam tu kan, dia isi secara single, then only they start to pairing up, to pair up. Okay, samalah juga for oxygen. Okay, start dengan 4 dulu, all the 4 sides, and then baru dia start pairing up. So as you can see neon, okay, neon, so all of the sides has 2 dots. Okay, fluorine ada satu lagi elektron yang tak ada pasangan. Okay, group 17. Okay, alright. Okay, so those are for the atoms. Atom form. Ini untuk ions. Okay, tadi atom. Now bila dia become ion, okay, tengok contoh lah. Hydrogen kan. Hydrogen kalau dia jadi atom, begini rupa dia. This is how hydrogen atom looks like. So we have hydrogen symbol and then 1 dot. Because hydrogen atom has 1 electron. So once the electron has been removed, so what will happen? There's no electron dekat valence shell. There's no electron dekat valence shell. Okay, so that's why dia H plus sahaja. Same goes to lithium. Okay, so we know that lithium initially we have 1 electron, 1 dot dekat situ kan. When the only electron dekat valence shell tu is being removed, there's no electron pada valence shell. Okay, that means we can write the lithium, okay, with the charge but without the dots, tanpa dots. Okay, same goes to beryllium. So initially this is how beryllium atom looks like. Okay, we have two dots pada beryllium symbol. Okay, but once the 2 electron has been removed, dia akan jadi beryllium 2 plus saja. So it shows that the valence now valence shell tu, there's no electron in the valence shell. Okay, that's why kita tak tunjuk dots. Same goes to boron 3+, C4+. Kalau, okay, this is very unlikely lah. Tapi kalau if it happens, that means dia jadi C4+. But this is different, okay, for an ion. An ion dia berbeza. Remember, because an ion they accept electron, right? So the electron will be added in the valence shell. Dia duduk dekat valence lah. Okay, so this is carbon kan. Katalah carbon accept 4 electrons. So these are the electrons in the valence shell for carbon. Okay, so for that you have to have bracket and don't forget the charge. Okay, so this one you tak ada dots but you have the charge. Okay, but this one you ada dots and the charge. So as you can see, okay, dia punya dots dia semuanya cukup 8 dekat situ except for hydrogen. Hydrogen dia duplex. Okay, dia become H minus. It can become H plus and it can also become H minus. Okay, nampak tak dia punya nitrogen, dia punya dots dia tu ada 8. Okay, alright. So this is for an ion. Right, moving on. Okay, draw Lewis dot symbol for the following atoms or ion. Okay guys, tolong buat, saya bagi 1 minit for this one. 1 minute for bromine, bromide and also bromide, okay? Okay, alright, so bromine atom. Bromine atom has 7 electrons. That means we have 1, 2, 3, 4, 5, 6, 7. Okay, so obviously dia akan ada 1 elektron lah. Okay, yang unpacked electron there. This is for bromine atom. So bromide, okay, they become ions the moment it has ion and then it is an ion. So dia ada 8 electrons lah. Okay. Don't forget the bracket and the charge. Okay. Right.
Madam, yang untuk A tu kita tak buat kotak madam?
Oh ya, yeah. Yang ada kotak hanya untuk an ion saja.
Oh,
okay. Normal atom tak ada kan? Ha, ni tak ada. Okay.
Tak, I miss ingatkan apa masih buat kotak itu kan. Okay.
Apa dia?
Sebab yang dekat tadi tu dia first tu dia kan dalam kotak, so ingatkan kena buat.
Oh yang ni. Ni ke kotak ni ke yang saya tunjuk ni? Tak ada. Bracket is only for an ions. Okay, it's only for an ion. Okay, next we are done with first part of topic 3. Next is subtopic 3.2. Okay, ionic bond. Okay, alright. So these are the learning objective for this subtopic. So make sure that you once you have completed this subtopic, you must be able to achieve all the learning output. Okay, learning outcome. Okay, right, moving on. An ionic bond is formed when one or more electrons are transferred from one atom to another atom and held by electrostatic attraction between positive and negative ions. Okay, so that is the basic concept of ionic bond. Okay, so the electron need to be removed, and kalau dia nak remove, there should be someone yang should accept the electron. Okay, right. So for example, sodium, it has 1 electron. On the other hand, chlorine needs 1 more electron in order to achieve octet. Okay, so sodium give out the electron to chlorine. Chlorine accepts the electron, okay, and it become sodium plus, macam jauh sangat je, sodium plus chloride ion. Okay, alright. So this is a stable form of sodium, sodium. Dia jadi sodium plus, chlorine becoming chloride ion. Okay, so as we know, these two are opposite charge. So opposite charge attracts one another. So that is what we call electrostatic attraction. Okay, due to opposite charge. Okay, right. So this atom will form positive and negative ion, and they are held by electrostatic attraction. Okay, so the one that transferred the electron will become cation. The one that lost electron will be known as cation. So conversely, chlorine ataupun the one that gains electron will become the anion. Okay. Alright, so use Lewis dot symbol to show the formation of MgF2. Okay, alright, so you have to have arrow, kena the arrow to show the formation. This is what we call mechanism. Okay, without the arrow, if the question asks for mechanism ataupun show the formation, the word show the formation, you need to have arrow in it. Without the arrow, marks will be deducted. Kalau dia kata just draw ataupun write the product form, that means without the arrow pun kita still give marks for you. But if they specified show the formation, okay, if you don't have arrow in your drawing, that means marks will be deducted. Okay, alright, so let's look at this question. Use with that symbol to show the formation of MgF2. So by right you kena ada that arrow lah. Okay, alright. So maksudnya senang cerita, buat je arrow tu. Kalau dia nak, maksudnya kalau show formation, that means we want the arrow. Kalau dia kata show the product form, without the arrow pun, you bagi arrow, you still dapat markah penuh juga. Okay, just to be safe. Okay, so please complete this checkpoint, guys.
Madam, untuk Lewis structure electrode diagram ni kan, kalau untuk positif kan, kalau macam Mg tu bila dia transfer elektron ke sebelah dia jadi Mg2 plus kan supposedly. So dekat structure formation tu kita kena tulis sekali tak Mg2 plus ke Mg sahaja?
Mg2 plus lah. Dia dah jadi produk kan? Dia dah jadi ion, so it should be Mg2 plus.
So kalau macam tu, kenapa yang dekat previous slide tu dia tak letak Na plus, madam?
Ni tu saya kata plus dia ni jauh sangat.
Oh.
To be here. Dia jauh sangat ni.
Oh, okay. Saya ingatkan dia tambah tu.
Dia tak payah dia tambah Dia tak payah dia tambah macam tu. Tak payah. Ni tak payah. This is not insist. Okay, because we know that sodium plus and Cl minus there is an attraction that is called electrostatic attraction. Okay?
Alright, madam.
Okay, kena adjust sikit lah bagi dia tambah dekat sini. Right. Okay, right. So let's answer this question. So we have Mg. Okay, so Mg has 2 dots. Okay, has 2 dots and H. Okay, and then Mg need to remove both of its electron in order to achieve octet. On the other hand, fluorine needs 1 more electron. Okay, needs only 1 more electron in order to achieve octet. Okay, so kita memang dah tahu kan, dia ada 1 je kat situ kan. Use dot dot. Do not use cross. Tak payah use cross because Lewis dot symbol. It should be dot, bukan cross. Okay, alright. Okay, so dekat situ Mg need to remove both of its electron. Fluorine on the other hand requires only one electron saja. Okay, alright. So this first this first electron will be transferred to fluorine. Okay, alright. So let's check. Fluorine is now octet, but Mg is not yet octet. Belum achieve octet. So because it has another one electron to be removed. Good. That's why we need another fluorine. Okay, we need another fluorine in order for both of them, all of the atoms present should achieve octet. Okay, alright. So this one. Okay, alright. So let's just check. Fluorine, the second fluorine is now octet, and same goes to magnesium. Okay, alright. So there, okay, all of them are now octet. Okay, so ini pun octet, ini octet, ini pun octet. So that's why dia akan jadi Mg2 plus because both of the electron has been removed, and fluoride. Okay, so we have two fluoride kan. So kita boleh kenapa saya buat macam tu So dia dah ada 8 kan. Alright, so we have 2 fluoride. So kita letak 2 dekat situ. Boleh letak 2 macam tu Don't forget the charge. Okay, ataupun you may also have fluoride in bracket ni, fluoride ion in bracket ada 2. There are 2 fluoride ion in bracket. So untuk simplify, so this is how you write. Okay, you write this the product of MgF2. Faham ya? Okay. Ataupun this is how it should be lah. Okay, just to check. Okay, that means you from the equation itself. Okay, from the chemical formula itself. That means this is positive 2, this is minus 1 kan. You must have 2 fluorine. Okay, you must have 2 fluorine and 1 magnesium. Okay, you must have 2 fluorine and 1 magnesium. This is just to check. Okay, kalau tak, kalau tadi saya punya reasoning tu, that's kenapa fluorine, why do we need 2 fluorine? Why do we need 2 fluorine instead of 1 fluorine? Okay, because kat sini dia ada conflict guys. So fluorine only one electron, but magnesium need to remove 2 of its electron. So that's why we need to use 2 fluorine. Okay, that's why we need to use 2 fluorine instead. Okay, right. So this is how you can also write ataupun draw the formation by using this. Okay, so nampak tak maksud saya tadi? You can use this 2, okay, or you can simplify in this form. Boleh, dua-dua pun boleh. Okay, but you need to have the arrows. Without the arrows, the mark will be deducted. Okay, maybe you can try out this one. We try lah. MgN2, magnesium nitride. Okay, boleh try Soalan at 7. Alright, okay. Next, lattice energy. So what is lattice energy? Lattice energy is the energy required to separate 1 mole of an ionic solid into gases ions. Again, okay, you have to specify the state. Okay, so it should start from solid. Okay, the what we call that, the compound itself, it needs to be in solid form. Okay, so how much energy is needed to remove the ions that form the solid? So that is what we call lattice energy. Lattice is only available for solid. Okay, so macam rumah kita ke something that is solid, dia ada lattice. Lattice means kekisi tau. Kekisi. Liquid mana ada segi-segi formation of lattice dekat situ. So that's why liquid does not have lattice energy. Lattice is only available for solid. Okay, bila dia nak form solid ataupun bila dia nak dia daripada solid ataupun dia to form solid. So anything involve solid, dia ada lattice energy. Okay, so this is the definition of lattice energy. As you can see from the equation, okay, sodium chloride in solid form, the energy needed to remove ataupun to separate them into sodium plus gas plus Cl minus gas. Okay, so this is the amount of energy required to separate them into their ions. Okay, lattice energy is a measure of the strength of ionic bond. Okay, so we use lattice energy to measure the strength of ionic bond. Okay, so there are two factors that can affect the lattice energy: ionic size and ionic charge. Okay, so ionic size, as ionic size increases, that means lattice energy decreases. So this is the same as what we have learned in topic 2 last time. Okay, so we know that when the size decreases, when the size increases, the attraction become weaker. So bila weaker dekat situ, by right the lattice energy pun lemah lah. Maksudnya energy required pun not as much. Remember, energy tu digunakan untuk separate the solid tu kepada ions-ionnya, nak pecah-pecahkan dia. Okay, so kalau the size increases, that means attraction is lower, weaker. That means the energy needed to separate them is not as high. Ionic charge, on the other hand, as ionic charge increases, lattice energy increases. Okay, remember, ionic bond is about positive and negative charge. Positive and negative charge. These two are totally different ataupun opposite charge, but they attracts. Okay, the more different they are ataupun in terms of the value, that means the charge will be stronger, the attraction will be stronger. So imagine if we have +1 dengan -1 compared to +2 dengan -2, which one will have stronger attraction? It will be this one. This one will be lower. Kenapa? The more different they are, lagi berbeza dia, lagi kuatlah dia punya attraction. Okay, so that is what it meant by as ionic charge increases, lattice energy increases. Now that means dia punya attraction tu sangat-sangat strong. So imagine if you have +3 and -3. Okay, so dia lagi kuat lah. Okay, so that's the idea of it. So as you can see, nampak lithium chloride, sodium chloride, potassium chloride, cesium chloride. This is down the group. We know that when we go down the group, the N increases, right? The principal quantum number increases. When the principal quantum number increases, the size become larger lah. The size become larger. So from there, we could say that the attraction between the ions become weaker lah. Okay, so this is proven due to the value of the lattice energy itself. As you can see, nampak tak dia reducing dekat situ. Okay, reducing. Okay. This is in terms of ionic charge. Like I said just now, this is +1 dengan -1. This is +2 dengan -2. Okay, so this one, as you can see, nampak tak? The energy is much higher compared to this one. Okay, alright, so we are done with that. Okay, arrange the following ionic compounds in order of increasing magnitude of lattice energy. Okay, so please make sure to complete this checkpoint. Okay, we will discuss it tomorrow. Okay, pun kita ada. Okay, alright, so physical properties of ionic compound. At least kita finish the ionic compound. Kita completekan this ionic bond. Tomorrow we can start with covalent. Ionic sikit je. Dah habis dah. Lepas ni ionic habis dah. The rest are all covalent. Okay. The rest are all covalent. Alright. So you know that the physical properties of ionic compound, ini benda yang sama. Okay. They have high melting and boiling point. Kenapa? This melting and boiling point is again due to stronger attraction. Okay. Stronger attraction. So the stronger the attraction, ataupun we can base we can base on the lattice energy also. Okay, the higher the melting and boiling point. Okay, dia akan based on the size and also the charge. For example, say the cesium chloride and sodium chloride. Cesium chloride located way down, okay, way down in the group. So maksudnya cesium chloride punya lattice energy we expect it to be lower than the sodium chloride. Nampak tak? Lower. Okay, that means the melting point should correlate. Dia kena tally lah. Okay, it should correlate. So 645 in terms of melting point, tapi tengok sodium chloride is higher than the cesium chloride. Same goes to boiling point. Okay, this is from solid to liquid. This is from liquid to gas. Okay, alright. Okay, ini pun boleh buat juga. Boleh buat sendiri. Okay, tomorrow kita discuss. Next, hard and brittle crystalline solid. So we know that ionic compound, they usually available in solid. Dia dalam keadaan solid. Okay, alright. If ions are displaced from their position in the crystal lattice, repulsive forces will occur. So normally they are available in solid. Maksudnya macam mana they are arranged in solid tu. Dia positif, negatif, positif, negatif, positif, negatif. Dia tersusun arrangement of the ions in the solid. Okay, alright. So imagine this is in solid form. Okay, so this is how they are attached together. Okay, imagine if this arrangement lari. Okay, dia displace, dia lari. Maksudnya you kacau dia, you disturb this arrangement. So what will happen? This crystal will become unstable and break apart. Dia akan pecah. So itu yang berlaku pada kristal-kristal. Kalau you ketuk dia kan, you nak pecahkan the crystal, you ketuk dia and it breaks. Okay, dia break. Macam mana dia break? Kenapa dia break? Because, okay, nampak ni. Dia displace. You ketuk dia, you kacau dia punya arrangement tau. So what will happen? Negative is now, okay, they are negatif sekarang meet the negative ion. Positif berjumpa dengan positif. Negatif, negatif, positif, positif. Nampak tak? Saya rewind sekali, okay. So as you can see dia disusun begini. Positif, negatif, positif, negatif, positif, negatif, negatif, positif. Sebab ada that attraction. Okay. Opposite charge attract. Tapi kalau you ketuk dia, you kacau dia, there will be displacement of ion dekat situ. So dia dah terganggu, so what will happen? Negative will meet the negative ion. Positive will meet the positive ion. So we know that this will repel. They will repel each other. Same charge will repel. So bila dia repel, dia menolak. Tu yang dia break tu, dia break apart. Okay, interesting kan? So that's why ionic solids are brittle. Bila you bagi force saja dia break. Okay, when struck they shatter because like charges repel each other. Yep.
Kalau untuk heat, the same juga ke? Dia jadi sama juga ke macam ni?
Heat?
Kalau kita apply heat yang high temperature punya lah.
Kalau heat dia due to dia punya dia punya attraction, dia overcome the attraction dekat situ. Okay, dia kalau heat dia mencair kan, kita tak nampak dia terpecah macam tu kan. Kalau solid dia akan pecah. This is due to this. Tapi kalau heat, dia more on the energy is used to break the attraction between positive and negative tu. Faham? The attraction to break the energy used to break the attraction between positive and negative. So dia break, so dia akan far apart. Bila far apart, the attraction become lesser. Okay, that's why dia become mobile tu. Dia boleh flow.
Kalau in case lah kita ada plastik kan solid kan, and then kita cairkan, kita tarik, dia punya bila dia dah keras balik, dia punya arrangement tu pun dah berubah lah kan.
Ya. Yeah. Tapi plastik dia cerita lain lah. Plastik dia polymer. Dia punya dia bukan konsep positif dengan negatif ni lah. Okay, dia polymer, dia pakai monomer tu kan. So itu dia, tapi dia ada that effect lah. Once you disturb the arrangement, dia akan form another arrangement yang which tak macam yang asal lah. Okay, so that is polymer punya part. This is ionic compound. Okay, so dia effect dia mungkin sama, tapi dia macam mana dia punya cerita dekat dalam tu, itu berbeza. Okay, alright. Alright, good electrical conductor in molten and aqueous state, and then solubility. Okay, ni saya nak highlight dia brittle, okay? Dia brittle. Brittle means rapuh. Ketuk je pecah lah. Okay? Alright, good electrical conductor in molten and aqueous state because kenapa? Kalau in solid they are locked in position. Dia terkurung, terstuck dekat satu place. Tapi if it's in molten state atau lebur ataupun dissolve in water, the ions are now mobile. Bila dia mobile, dia boleh conduct electricity. Okay, same goes to solubility. Dia boleh solubilize in water. Kenapa? Because water itself is polar. Okay, water itself is polar. Polar suka benda yang polar. So ions is polar, sangat polar in fact. Okay, so polar attracts polar. Okay, light dissolve light, polar dissolve polar. Right? Okay, we are done with that. Done for ionic bond. Okay, so tomorrow we're gonna start covalent and the rest will be covalent sampai habis. Ada satu je metallic bond. Okay, any question guys? I think there should be no question. Ada ke?
No, madam.
Alright, okay. Okay, so that's all for today. Thank you everyone. Please complete the checkpoint. We will discuss it tomorrow. Okay, thank you everyone. Assalamualaikum.
Thank you, madam.
Thank you, madam.
Thank you, madam.
Thank you.